Alrighty guys, welcome to 11.4, the fundamentals of probability. So here we're going to talk about two different types of things. First, theoretical probability, and then finally empirical probability. I'll just briefly talk about what those two are in a nutshell. A theoretical probability is the ratio of the favorable outcomes, the number of favorable outcomes, okay, divided by the number of total outcomes. In a particular scenario. So let's do a quick example. Suppose you have a jar with 100 marbles, right? And let's suppose that in this jar there are 30 red marbles, and then there's the rest are blue, whatever. Okay, there's a 70 blue marbles. Let's just pretend. Okay, so then the question is, what's the theoretical probability of selecting a blue marble? And I think most of you guys was correctly say, oh, it's going to be 30 because there's 30 red out of 100 marbles. And that's correct. It's 30% or 0.3. This is the theoretical probability. The empirical probability would be, okay, I'll tell you what. Let's go ahead and pick one marble at a time, 100 times since it's out of 100. And we're going to say, okay, so let's mix it up thoroughly. Grab a marble, and let's suppose we take a red one. Okay, great. Now you put you do almost like a checklist. Okay, how many times was it red? How many times was it not red? And then you kind of keep tabs, right? So the first one was red, the second one was not red, and then you keep doing it until you get 100. And once you do that, then you calculate how many you observed that were red in the 100, choosings. And this would be the empirical probability. Now the idea is that the theoretical probability should match the empirical probability always if you have very, very large opportunity, like a lot of opportunities to do it. So if you flip a coin, you know it's 50-50 to land on heads or tail. But if you flip it 100,000 times, then you're going to see, 50% of the time it's going to land on one side or the other. If you land it twice and it happens to both land on heads, for example, it doesn't mean, guaranteed 100% land on heads. Doesn't mean that. Okay, you have to do it a lot of times for the empirical probability to match the theoretical. Okay, so that's the theoretical. It's just basically it's just asking you how many times the favorable outcome will occur out of the total possible outcomes. The total possible outcomes, we'll call that the sample space. That would be like the 100 marbles in the example I gave earlier. So let's see. Let's look at the example here. Suppose you roll a 12-sided die that's labeled 1 through 12. Okay, so you have 12 different possible outcomes, right? It can land on 1 through 12, and that's called the sample space. This right here, that's set. It's a sample space. Now the probability of rolling a 4. Well, how many times can 4 show up? Just once out of the 12, right? So the number of favorable outcomes is 1 because it can only show up 4 once, and it's out of the 12 possible outcomes. So this is what we call the theoretical probability. Let's do another example here. It says here, another one. Suppose you roll a 12-sided die, and then what's the probability of getting a number greater than 4? So let's think about that for a second. Well, actually, I'll do it in this one here. Greater than 4 are all of these numbers, right? There's 1, 2, 3, 4, 5, 6, 7, 8 numbers that are bigger than 4. So you have 8 different options or 8 possibilities out of the 12 to get something bigger than 4. So that would be the probability, which if you simplify that, you can divide both by 4, you get 2 over 3. So there's 2/3 chance or a 66% chance, however you want to interpret it. Alrighty, let's do this exact guided example. I'm assuming, that's 4 examples here. So it says here you have a 6-sided die. Okay, that's a normal die, right? And you roll it once. Perfect. What's the probability of landing on 2? Well, let's think about a 6-sided die. What's the sample space? In other words, what are the possible outcomes? In a typical 6-sided die, it goes 1 through 6, right? It's not like it has 4 ones or anything. So there's 6 possibilities, so it's out of 6. And how many of them are 2? Just one of them. So it's 1 out of 6. Simple as that. How about less than 4? Well, let's see. Less than 4 includes 1, 2, and 3. That's 3 numbers out of the 6 numbers. So if you simplify, that's 1/2. How about greater than 7? Wait a second. There is no number bigger than 7. So it's 0 numbers out of 6, or there's a 0% chance of that happening. How about less than 7? Well, less than 7 is every number. So it's all 6 out of 6, or 100% chance of that happening. Well, that's pretty simple. Alrighty, so those are the answers. You guys want to see it? I'll be sending you these notes anyway. So let's go ahead and do the next one. Six-sided dice rolled once, find the probability. Okay, so it's a six-sided dice, so we're going to go ahead and just put the sample space so we can know what we're talking about. Oh my gosh, my handwriting. 3, 4, 5, 6. Okay, the probability of getting a 4. So there's only one 4 out of the 6, so it's 1 6. An odd number. So an odd number is any number that's not divisible by 2. So 1, 3, and 5. Those are the 3 odd numbers. So 3 divided by 6, or 1/2. Excellent. A number less than 20. Well, every single number there is less than 20. So it's going to be 6 out of 6, which is 100%. Or a number greater than 20. There's no single number is bigger than 20 there. So it's going to be 0 out of 6, or 0%. Okay, these two parts are kind of silly. Okay, so that's it for this lesson. Let's talk about the empirical. Yeah, empirical probability. That's the next one. So the empirical probability is kind of, sometimes it's testing whether the theoretical is accurate. Because let's suppose you go to a casino, right? And you get a die. You're playing one of those games where you throw a die, and you feel it's loaded. Theoretically, it should have a 1 in 6 chance of everything to be showing up, right? But you notice that it's always landing on 1 more often or something. It's weighed differently, so it always has a greater chance of landing on 1. You can test that empirically. Well, first you can actually test it by measuring, right? Weighing it. But if you wanted to test it empirically, you just roll the die 1,000 times and see if 1/6 of that is equal to 1. If it's greater than that, then you start to wonder, is it a loaded die? Anyhow, so that's empirical probability, is to actually go ahead and observe the favorable outcomes occur in the total number of outcomes that you did it. So if I, for example, the marble, I select one marble at a time 100 times, and I count how many were red. Let's pretend it was 31 that were red. Okay, great. It'd be a 31% empirical probability based on my observation. So let's see what there's an example here. Suppose you toss a coin 8 times. So and heads was observed 6 times. What's the probability heads will occur? So it would be 6 out of 8 because you observed it 6 out of the 8 throws. Now that's not theoretically true, right? Theoretically it should be 1/2. But again, you only threw it 8 times. Theoretical will only show itself to be accurate with very large numbers of trials, right? So anyhow, what is that? 3 divided by 4 divided by 2. So it's a 75% chance according to the empirical observations. Let's see. However, the empirical probability is okay. That's the answers. All right. The theoretical of a coin toss is still 1/2. So the probability of tossing okay. So we know that. So you're asking, why is there a conflict between theoretical and the empirical? Only because the empirical will be closer and closer to the theoretical with larger and larger sample spaces. It's very important. Okay, or trials, or whatever you want to call it. So here you go. Example. You have a table here. It shows a bunch of information. It says male, female, and then they have a total. And then they have action movies, comedies, total. Okay, so the information is pretty much this section here. So this is a survey, right? If one person, okay, so here we go. If one person selected, randomly selected, what is the probability that person will prefer comedies? So even though this is a two-way table with information very specific, it tells you 2 things about the person. It tells you their gender, right? And then their movie preferences, right? So this is like their movie preferences. We're only worried about the preference. We don't care about the gender. So how many people like comedies? Well, 37 people like comedy. Out of how many people were sampled or asked? 56 people were asked. So it'd be 37 out of 56. Okay, the answer is right there. All right. So let's see. All right, here we go. Guided example. If one person is randomly selected from the population from table 1. Okay, so this table down here. All right. Let me actually erase that. Looks weird. All right, so then it says find the probability expressed as a decimal, round to the nearest hundredth. That person. Okay, that person is never married. So let's see. Never married is this group of people. They don't care about gender. They just ask for never married. So it's 74 out of the total 242. So we're going to say 74 people out of the 242. How about if they're male? So again, it's not asking about whether they're married or not married or divorced or whatever. Male, just in total. If we look at this row, we see there's 118 guys out of the total 242 people surveyed. Okay, this is the total surveyed. All right, what's the next question? That's it. Okay, let's do this one together. We're going to use the table to find the probability expressed as a decimal rounded to the nearest hundredth. I'm just going to leave it as a fraction, guys. Later, you can turn it to a decimal if you wish. All right, what's the probability that the person's an owner? So let's see. I don't care then about this, these columns. I only care about the rows. So just this one. So there's, they don't have the total added up. So I have to get a calculator. Add this up. So we're going to add all these people, and then that's the number of owners, right? But then we have to add all 6 of them, because that's the grand total of the whole group. So we're going to have to do a little bit of adding. So let's do that quickly. Let me just put in my calculator. 11.7 plus 2.8 plus 0.3. So I got a total of 14.8 owners. Let me put the plus 18.7 plus 4.5 plus 1. And there's a grand total of 39. I added 14.8 plus all of these, and it gave me 3. So my answer would be 14.8 out of 39. Okay, so that's all I care about. I don't really care about the renters. So see, the person for B, the person who moved within the same state. So again, we look at this, moved within the same state as this group, moved this in state, we don't care about them. We do know that the grand total is 39, so we're going to say out of 39. And let's see, 11.7 plus 18.7. It gave me 30.4. So there you go. So this would be my, I know it's not a decimal, I'm supposed to turn it to a decimal, but that'd be my probability, my empirical probability based on the table given. So that's how you do it. Let's see what else we got. Oh, we're done for 11.4. So I hope you guys enjoyed this video. I'll see you guys for 11.5.